All right, lesson number 2. Our big idea continues to be that there are many ways to represent numbers, and knowing what those numbers mean helps us to compare things and to solve problems. And in fact, today our concept is about demonstrating an ability to solve problems with large numbers. So knowing what that number is helps you to figure out how to add or subtract or multiply or divide it. We add, subtract, multiply, or divide numbers to solve problems. Addition, subtraction, multiplication, and division are what we call operations. And we use numbers to understand and describe our world, and that's how we use them to solve problems as well. All right, we're going to look at the connect section of this lesson. This would be lesson number 2 in Unit 2. Here we have a problem for us to look at. The population of Canada was about 32,980,000 in July of 2007. Data showed that there were about 497 cell phones per every 1,000 people. So about half had cell phones. How many cellular phones were there in Canada in 2007? Well, first we need to find out how many groups of 1,000 there are in 32,980,000. To find that out, we're going to divide, and these are large numbers. You may use a calculator. Whenever you see that little calculator symbol, it means you're definitely able to use a calculator to figure that one out. So let's take a look. 32,980,000 divided by 1,000 is going to leave us with 32,980. We're not done yet though, because this is a two-step problem. We want to know how many cell phones. Right now we just have how many groups of 1,000. So if we know that there's about 497 cell phones for every group of 1,000, that means this many groups of 1,000. Each of those groups has 497 cell phones. So we need to multiply those two numbers using your calculator. Those are large numbers. 32,980 multiplied by 497 is going to leave you with 16,391,060. So that's approximately how many cell phones there are, because this is an estimated number of people. So that right away makes this an estimate. We can confirm that our answer here is correct by also estimating. We're going to use benchmarks. 32,980,000 is pretty close to 30 million, closer than it is to 40 million, so I'm going to make it 30 million, divided by 1,000, because we want to know how many groups of 1,000 there are, which make it 30,000. 497 is closer to 500 than it is to 400, so 30,000 times 500, which would give us 15 million, which is very close to 16 million. And so we know that 16,391,060 is a reasonable answer. All right, we're going to do some practice. Now, I didn't want to use book questions out of your textbook today, so we're going to look at Maximizing Math, page 7, and these are the questions that we have. Now, this is also practicing large decimal numbers, because we have 4.88 million of a meter. So remember, this is 4.88 million. So we need to change these, first of all, to standard form in order to be able to work with them. And then you're going to determine which one is larger and how many times larger. So let's start by putting each number into standard form. Press pause and put them into standard form now. All right, so 4.88 million, remember, is 4 million, and the rest fills in. So 880,000 would be our standard number for that one. 12 million, 12.1 million, so 12,100,000 would be our next one. 12.758 million, so 12,758,000 would be our number there. 6.794 million, so 6,794,000 would be our standard number there. All right, now that you know the standard number for those, go ahead and determine how much larger the diameter of Venus is than the diameter of Mercury. Just so that you have an understanding of diameter, because we haven't really come across that in our curriculum, but it is in the textbook. Diameter is the distance across a circle from one side to the other. All right, so you're determining how much larger the diameter of Venus is than the diameter of Mercury. All right, so how much larger really means the difference. And when we know it's the difference, we know we have to be subtracting. So we're subtracting the diameter of Venus and the diameter of Mercury. Venus is the larger number, so it goes first. Sorry. So 12,100,000 is the top number. 4,880,000 is the bottom number. And remember, when we are adding or subtracting, we always line up by the decimal place. So ones and ones, tens and tens, hundreds and hundreds, and so on. First part is easy. 0 minus 0 minus 0 minus 0 is always 0. 0, take away 8. We cannot take 8 from 0, so we are going to have to borrow. That 1 is going to become 0. And this 0 becomes 10 because we're lending 10 over. 10 take away 8 is 2. But now we still have another 0, so I'm going to have to borrow again. My 2 becomes 1. My 0 becomes 10. 10 take away 8 again is 2. 1 take away 4. Can't take 4 away from 1, so I'm going to have to borrow from this one. It's going to become 0. This one is going to become 11 because I'm giving it 10. 11 take away 4 is 7, and 0 take away nothing is nothing. So 7,220,000 is our answer. That's how much larger Venus is than Mercury. All right, now we're calculating how many times larger the diameter of Venus is than the diameter of Mercury. How many times larger is multiplication? How many groups, or how many Mercuries really, can fit into Venus? So we're going to have to divide, because we're taking groups of and dividing it into groups of Mercuries, basically. So definitely going to want to use your calculator for this. 12,100,000 divided by 4,880,000. All right, so we end up with 2.4795, or 2.4795, and it continues, big decimal number, but we know it's about 2 times larger. All right, and now you get to move on to your concept practice. This allows you to practice the skills. It will become homework. We will mark and discuss it. Your concept is demonstrating the ability to solve problems involving large numbers. Because they are large numbers, you may use a calculator. However, when you use a calculator, you must still show work. And by show work, I mean show what you punch into your calculator. So if I punch in 12,576 plus 2,379, that's what I want to see written down. It doesn't mean I need to show all the borrowing and the carrying, but I need to see what numbers you punched into your calculator. Make sure that you show that. And you are working on page 52 and 53, numbers 1, 3, 4, 6, and 9. Make sure you fully read the question to ensure that you have fully completed the problem. Some problems need more than 1 step. Some problems need 2 steps. Some problems need 3 steps. So make sure that you look at the question and determine whether or not you have fully completed the answer. If you have problems as you go along, remember you can look back at your Connect section. You can look back at the video. You can ask a desk mate. And of course, you may ask me. So make sure as you work, if you have any questions, that you let us know. Away you go.